Okay, so my talk was kind of open-ended in the sense that, what were reflections, and we're not talking about ray tracing, we're really talking about looking back at time and thinking about what things are going to be in the future by looking at where they were in the past. So my background, I'm a licensed architect, I'm also an author, and I've been heading up leading software products for about the last 20 years. I joined Chaos just last fall. And here I'm leading the team of product managers and product specialists, also known as expert users within Chaos, to make the products as good as possible for you as users. So we're also in the process of building, so if you are interested in a role that really helps define where our products go and how they can be as good as possible for the entire artist community, drop by our talent booth and we'd love to talk to you. So while I've only been here a little while, I've actually known the Chaos Group people for a long time. I've known Peter, Vlado, Lon, Boris for quite some time. I've known V-Ray actually from its inception, from its very first version. I actually have been on the other side and licensing technology to Chaos Group. And over time, I've actually promoted V-Ray and V-Ray GPU all around the world. So these are the companies that Lon mentioned that I've worked with. These are the actual products that I've actually been under me or under my teams at those different companies over time. Now, what that's done is given me some experience in quite a few different areas that all come together to be really important for Chaos Group going forward. So many of the things that you heard about in the keynote kind of all dovetail together in what my background is, and that's why I'm here. It's an incredible opportunity with amazing people like you saw present earlier. So as I said, sometimes the easiest way to see where you're going is to look where you've been. Even the military does this with reconnaissance video. They actually play it in reverse to actually see where the supply depots are. But we're going to do that with technology. And today, what we're going to do is just kind of take a step back and use 3ds Max as a bellwether for how technology has changed. I picked that because I assumed many of you know 3ds Max. How many are Max users in the audience? I guessed right. Okay, good. Then we'll take a look at how things have evolved, and then we're going to plot that against where V-Ray is next is being designed and what possibilities could go forward. Okay, so this is just this is the only timeline you'll see. It's giving you a quick view of what's happened in the world over time. If you take a look at where 3D Studio started way back on the left-hand side, and the transition over to 3ds Max, that's actually the time period it took to build Max between R3 of DOS and 3ds Studio Max. V-Ray then came out really soon, right after 3ds Max, and continued for the life of it, obviously. One interesting thing is when you take a look at the bottom here is what was just coming online when all of that was being done. The internet had just become public. There weren't even any graphics APIs. The first GPU didn't come out until several years later. The first multi-core, dual-core CPU didn't come out until many years later, or did a 64-bit operating system. So a lot of decisions had to be made really early to give us the foundation for what we have today. So if you remember this one, how many go all the way back to this level of 3D Studio? The veterans. Okay. So if you remember what this was like, it was 5 modules, everything was explicit, every decision you made was permanent. You had to constantly save and fetch because there was no undo. There was no way to even interact with your model. You basically had to drag a mouse and hope as you let go. There was no viewport shading, no internet feedback whatsoever. But it had the beginnings of a plug-in system, and that made a lot of sense. But the most important thing to plug in, a renderer, wasn't there. So at Autodesk at the time, or I should say Yoast Group, who were building this, they decided, well, I should say, that gave me a lot to write about. That stuff was so hard to use that gave me the opportunity to write books about it, and that's actually how I got into this industry. But none of that was very good, so everybody wants to get rid of all that. And that was kind of the focus for what they did in building the 3ds Max architecture. So now we come over to 3ds Max. A few more hands might come up this time. And suddenly it was a huge shift in what was possible. Suddenly you were a 32-bit operating system. Everything was flexible. Everything was interactive. Everything was, undoable. You could get constant feedback as an artist. Your world basically changed. It was kind of like stress-free modeling, when before every single mouse movement was kind of like terror. It wasn't actually going to work or not. Also, everything in the system was basically designed as a plugin. And most importantly, plugin renderers were not possible. So very soon after the first 3D Studio Max, we started getting renderers coming out for 3D Studio Max as well. And that gave me a lot to write about too. So not just one volume, but 3 volumes of books actually went into documenting how the first 3D Studio Max changed everyone's lives from the previous version. Now, those were the features. That's what you saw as an end user for how it changed your life. But it was actually built on these trend predictions. Way back in 1993, this was what they were betting on that was going to really change things. First of all, the old program was all written in C. It was all very linear. Everything in there was completely linear code. They completely switched it over to object orientation, and that's what gave you all the proceduralism and freedom that Max has. NT gave you multitasking and many other things, and everything was, from the very beginning, was multi-threaded. Now, this was a time when multi-threaded meant that you had a dual processor machine, because there wasn't anything more than that. Remember, multi-core machines didn't come out for 10 years later. And there wasn't a graphics API, but we knew there would be. So the whole thing was built around being able to plug in your own graphics API. Very smart move. With one big risk. Basically, they were forcing everybody to buy new hardware in order to upgrade to this from what they had before. And it was actually slower than what you had before as well. But over time, it proved to be the right thing. Looking back again at where the market was in 1993 when Max first came out, this was kind of how it was. On the PC, you basically had 3D Studio. On the Amiga, you had Lightwave. And all the big guys were over on the SGI. And those were these colorful boxes or refrigerators that you may remember. This is what dominated the world for over a decade, and what we were facing when we were designing 3ds Max. And the logic was, that's going to fail, and we're going to bet the farm on Windows NT. And 4 years after Max, this is the landscape. All the SGA software is in maintenance mode. Windows, all the old SGI software has moved over, actually onto new generations. Lightwave's in parentheses because it never really got a next generation. And all this hardware is what was powering everything. This is what transformed it, because it had the exact same killer feature set that we needed as artists, but it was super affordable. And that's what changed. Now, the SGIs are still around, but now you're starting to see things like this, where these $100,000 boxes were being turned into beer kegs. So now let's take a look at those bets. They put big bets early on Max 1, and what did that change going over to Max 2019? Well, first of all, RAM. You can have 170 times more RAM now than you could before. And it's 1,000th the cost. No kidding. It was $40 a megabyte, now it's $40 a gigabyte. CPUs are over 1,000 times faster. Not just in megahertz, but if you add in the cores and hyperthreading, you get to 1,000. GPUs are also over 1,000 more. This one I couldn't even calculate. It's too hard to calculate, but it's big. The memory you can calculate, and amazingly, when we launched, the biggest card available was a 24 meg card from ELSA. Now, the latest one from NVIDIA that they're giving away as a prize for the Mars project is 1,300 times more memory than you had before. So now let's take a look at what these trends were. These were disruptive. That's what things were built on. And what does this relate to today? What are parallels that we can make? Well, parallelism or multi-threading actually correlates directly to the cloud. You saw Boris with 15,000 cores. Imagine that at your fingertips anytime you want. Object orientation was groundbreakingly different for programmers and what they could do. It is no less groundbreaking now with deep learning and artificial intelligence. Dedicated graphics, we are now coming up to a next generation of graphics APIs with DXR that Steve talked about, also with Vulkan, Metal. All of these are new opportunities that advance what is possible with graphics. And memory size is really not a problem anymore. Yes, you can run out, but you can always get a bigger machine with more RAM if you need to, because you can get into the terabytes of RAM today. But now going forward, what will change is, let's talk about GPU memory, because that is where things are still holding us back a bit. And now one thing when I looked at this over time, which was interesting, is that if you plot the memory of Windows systems versus that of GPUs, they kind of correlate in the sense that when Windows goes up, so do the GPUs. Now, the scale of those two are completely different. When we put them together, though, it's nearly flat. The GPUs are way down there, as opposed to the system's RAM. But we'll come back to that in a little bit. So now let's take a look at the trends that we just talked about. These are the new trends. Now let's talk about how these are being affected or planned for in V-Ray Next to exploit. Because we're really looking forward at the underpinnings for what's going to last us a long time so that we can come out and keep exploiting all the new innovations that we know are going to happen. This is kind of what Vlado was talking about early on. So the cloud, Boris showed you what's happening with Chaos Cloud. That's going to get enhanced considerably. We'll talk a little bit more about that. Deep learning, you saw the beginnings of that already happening in V-Ray. V-Ray Next is getting very smart in how it is interpreting the scene, doing things for you as much as possible. All that is little baby steps on AI. And then, of course, the denoiser is actual true deep learning in action. Next-gen graphics, V-Ray Next GPU is set up to take advantage of it. This version is dramatically better than all previous versions and over twice as fast and extremely feature capable. If you haven't tried V-Ray Next GPU yet, I really encourage you, especially, we're talking about in 3ds Max. And then the memory size, that also really changes with something called NVLink. So V-Ray GPU was the first renderer and still is the only commercial renderer that supports NVLink. And that kind of changes things. So let's bring up that memory slide again. Can you see that? Anyways, so once we put in the NVLink systems, suddenly you can't see it. Imagine, if you will, basically the systems that Steve was talking about actually come up and equal what's possible on a standard on a Windows system. So 512 megabytes of RAM, or about half that with the previous systems. The thing, though, is that those are still pretty exotic machines. This sounds like it's a throwback to SGI for a second. $400,000, $150,000 machines. Who can afford that? Well, when they become available in the cloud for very affordable per hour, per minute pricing, everyone can afford it. And so it doesn't need that you're going to be excluded from taking advantage of so much horsepower. So let's think about, now, caveat, everything I'm going to talk about is what if. These are not promises, but they are possibilities that we're pretty excited about. We believe that Very soon, the smallest shop will be able to compete with the biggest studio if they want to. You'll have as much rendering power at your fingertips as you want to fire up, and as easy to use as Boris was showing with the V-Ray Cloud Beta. And the next thing is that once you have your data in the cloud, you can do a lot with it. You can suddenly share it. We can make it interactive. And that's what Boris's second demo is all about, is imagine that is now running in a browser, on a phone, on a tablet, anywhere in the world. It could be your client, it could be your mom. And they could actually interact with your scene without ever knowing anything about 3ds Max. Exactly the same fidelity and rendering that you authored now can be viewed by anybody. And this is what I'm saying, is that when you'll be able to easily share with everyone that needs to review, whether that's a director, a client, a supervisor, a colleague. All of that can be shared very easily through leveraging the cloud infrastructure. And those reviewers will be able to do it as easily as playing a 3D game. That's the idea, is that everything that you're working with, regardless of the tool, whether it's Cinema 4D, Maya, Max, SketchUp, all of that comes to a common rendering format at the end of the day that then becomes a universal format that you can explain and teach your designs to whoever you need to. So AI and deep learning are extremely exciting. They are more revolutionary than object-oriented programming. It is dramatically changing the way things are programmed. It's a very exciting time for what is possible. The way you can think about it is, if a human is good at it, deep learning is probably good at it too. Humans are excellent at pattern recognition, about taking information and making decisions based upon the images they see. That's what deep learning really is built around. Well, everything we do is visual, and we can leverage that in many techniques across our systems, and we're beginning to explore that and getting some exciting results. An example of that is you may suddenly, like for example, if you want to do super hyper-realism today, it takes forever to get the dirt and grime and randomness and all the awkwardness of a built or natural environment. It takes a lot of time. This could all be as easy as a paintbrush with AI. But it won't replace people as much as empower you. So I believe that we can enhance artistic expression and have it learn for how you work, what you like, and let you be more of an artist than a technician as you are creating your designs or your visual effects. Next, GPU memory is not going to be a barrier anymore. Whether it's in software or hardware, it just won't be a problem. It will all just work, which means that all of your scenes will be able to leverage the power of the GPU, which basically means that your speed-ups will go between 10 and 20 times faster than running on the CPU alone. What this, of course, means is that much faster feedback, much faster creative iterations on your decision-making, and your throughput should jump. Now, what we've seen is that most artists just consume that and make their work better and better. You know, you always say, well, I'll get my work done faster. Not usually. Usually you just keep consuming how much you can do to try to make it as good as possible. And finally, the cloud will give access to hardware that you can't otherwise have. No matter what happens in hardware, there's something called heat and power that will limit what a laptop or a tablet can do. The cloud liberates us from that restraint, and so that we can take the interaction and power of remote servers, like in Google Cloud, and bring it to anywhere. The next is new graphics APIs. So Steve showed this video earlier on. This was coming from Epic, as he was saying, and it's using the new ray tracing extensions in DirectX. Vlado's already done a blog about this. We're already experimenting with this, and we're getting some very encouraging results. And so you can expect, even in the nearer term, some interesting things coming from us around exploiting the new graphics APIs. What this means is if games are starting to use ray tracing, it's going to force the price of hardware and the capability price of hardware down and the capabilities of it up, because the business opportunity is too great to ignore from the likes of NVIDIA. So this is all good for us in the visualization and VFX world because we will benefit from that as well as those things come down. Once it gets really fast, once it becomes no memory boundaries, you are going to be able to work in true realism all the time when you're making your decisions. Forget about working in proxy mode or in a low resolution mode or in a draft mode. You'll just basically be working in your rendering all the time. And that's where things are headed and where we're building everything to finally achieve. And through all of this, I believe that Chaos is uniquely situated in being an expert in ray tracing and with some of the best customers in the world, that we can extend the possibilities of all of this new technology much farther in what we build going forward. So while I head Epic here, just closing on one little thing here, in case you haven't been, how many people here have tried the the V-Ray for Unreal Beta? Only a couple, okay. You don't count. Okay, so give you an idea, this is your viewport in 3ds Max. You work in 3ds Max as normal. You create your V-Ray scene as normal in 3ds Max. And then you basically export it as a VR scene, bring it over to Unreal, and all of your decision making now becomes real-time shaders. It's that simple. You don't have to know anything about conversion into a game engine to make this work. It all works for you. And then once you're in Unreal, you can go back and get your V-Ray rendering anytime you want to directly from Unreal. So we're thinking that this is an example of interactive real-time workflows that will be changing things. And when you merge that with the new graphics APIs we're talking about, some really exciting things can be happening. So that was the end of my talk. It's a little shorter than normal because I wanted to leave time for HP, who are going to come up and talk to you about the Mars project that we have. We have Barbara Marshall from HP. She's leading that effort. And if you liked anything that you heard, if you're excited about what we're building and you want to be a part of it, stop by the talent booth. We'd like to talk to you. Okay, thank you.